Alright, hello everyone, and welcome to another video where we're building our own operating system from scratch. Today we're going to get into numeric expressions. That's going to allow us the ability to do to have the assembler do calculations for us, addition, subtraction, and multiplication and division. But before we do that, let's get into as always, fixing little mistakes that we had from last time. So we're going to go ahead and start a new branch for this video. And we will get in and so right here I'm going to spell I said multiply, multiple, I meant multiply. There is also down here at the end of the instructions is a curly brace, and that should really be a right paren. And then the other thing was that right here I just pasted base 10 from somewhere else, and it really should be like that. So I think that was it. So let's just go ahead and make a commit there. Okay, so numeric expressions. I found a while ago. I found a blog series by, and I'm going to get this name wrong, and I apologize, Ruslan Spivak, and he has a blog series where he's building a simple interpreter to interpret Pascal from Python, if I remember correctly. So this new numeric expressions comes straight from him, and there's also some other stuff that we're going to do down the road that we're going to kind of follow the same techniques and patterns that he used in building out his interpreter. The other thing that I decided to do was I decided to order the special thanks area to be chronological rather than to be the way that it was originally. So that's just what the changes there are. So let's go ahead and we'll just commit that as a separate commit. And let's go ahead and take a look at our code, and we'll get into explaining what we're trying to accomplish. Actually, we need our input file. So here in the times, we've just hard-coded 508, and that's because the boot sector needs to be 512 bytes long. We have to take 2 bytes for the boot record signature, and then the jump back to loop instruction takes 2 bytes as well. So that gives us 508. The problem here is that if we were to add any other code, which we would be allowed to do, so for example, if I wanted to say right here, just go ahead and add, I don't know, 1, 2, 3. When we go ahead and produce this this binary, and I actually run the assembler, we can see that the boot record signature has been shifted because we've added that 1 byte to the output. So the fix for that, of course, is to change the 8 to a 7, but we don't want to have to do this every time. We want some way where we can specify how many zeros to put in based off of what the assembler knows about what's happened already in the boot sector. Ideally, we would want to do something like, you know, we want to end up with something like 512 minus 2 for the boot record signature minus, you know, like the current location in the output. Okay, but in order to do that, we are going to have to be able to evaluate this expression, which is what the numeric expression is. So it's just a way to have the assembler do some math calculations for us, and we'll get into figuring out how we can say where we currently are if we have time. But the main goal right now is to be able to just say 512 minus 2 for the boot record signature minus 2 for the loop up here. Okay, it's not much of a difference, but it's going to enable us to do these math calculations, which is going to be handy for in the future. So what we should probably do is go ahead and open up our grammar file just so that we can keep that up to date. And so we're going to have the first thing that we want to add is a way to do expressions. So I'm going to go ahead and say we're going to call it a numeric expression. And what that's going to look like is we're going to have numeric followed by optionally wait, that's repeating. Okay, let's just write it out and we'll fix the actual syntax here in a second. So we want to be able, the first one that we're going to tackle is addition and subtraction. So we want to say that you can have either a plus or a minus followed by another numeric. Now, so we want to be able to chain as many of those together as we want. Oh, that's right. The optionally one allows for the zero case. So that, okay, sorry. So if we do that, that's great, but we're not using it yet. We want to be able to take advantage of that. Ideally, right here in the times. So that's going to so that's really the change that we need to do. Is now instead of just accepting a decimal after times, we need to accept a numeric expression, which is a numeric, which is a decimal or a hexadecimal, optionally followed by as many plus or minuses in a numerics as you want. So if we we'll want to, I guess, yes, that is in the assembler. We want to go here and we'll want to well, let's take a look at the times portion. So right here we have times, and what happens is if we get we look at the next token, right now it's expecting it to be a decimal, but now it needs to be, now we need to accept either a decimal or a hexadecimal, and then optionally as many additions or subtractions as we can after that. Okay, so let's make this change. So we want to add the ability to be able to say hexadecimals are okay. And so that code right there, that would work perfectly fine. It's the same code that we have down here when we're actually handling a jump. So we know that that's okay. So that's going to handle that first one that's required. What we want to do now is say, while we're not okay here. So I think right here we're going to want to then update the token. I don't know why I did that. I can just use that. So we're going to update the token. Now, here's something that could be of a concern. So that's going to take us then to the DB token, or the defined byte. If we want to be able to then execute the defined byte code, if we go all the way through, we're going to advance again and we're going to lose that defined byte token. So I hadn't thought of that, to be honest. I'm wondering if I want to split this else if and just have it be if. The other option would be we could copy, we could basically peek at the next token and see if it's a defined byte. And if it is, then just don't update. I think what I'm going to do is I'm going to change these to be, instead of else ifs, we'll just have them be ifs. Because I don't think that they're going to collide with each other. Because a jump should be followed by a numeric, and then that should be followed by the end of line, which we're not actually handling, we're just kind of skipping over it for now. So I think this will be okay. So we'll go ahead and update the token. Then what we'll say is, while the token type is not a token type defined byte, and actually this is going to be a for loop because we want it to auto advance for us as well. Similar to our outside one. And in reality, we could do that. It's maybe a little ugly. I don't know. Anyway, that's easy enough to change if we don't like it. or if it gets confusing. Okay, so as long as it's not a defined byte, what we want to do is we're going to expect it to be either a plus or minus. And then we expect a numeric. Okay? So and then if it's a numeric, basically we want to do this piece. But this is going to be with an operation. So we'll need some kind of an operator. So what we'll do is we'll just say add operation. And if it's an add operation, we want to say that the times value needs to be, the current token value needs to be added to the times value. Otherwise, the times needs to be subtracted, or current token value needs to be subtracted from the times value. Okay. And times starts out at 1. And that's fine, because what we're saying so far is that it has to start with a numeric value. We're not currently allowing like the unary operator saying like -4. So we can't ever have it be a negative. So we're going to have a value in times, and then we just need to do stuff to it accordingly. All right, so all we have to do here is figure out what token type it is. So we can actually probably just inline this and just say if the token type is equal to let me double check what I would like to call them. I would like to call them plus sign. Then we will say an add operation is 1, otherwise it's 0. All right. So I think that's going to be the code that the assembler needs to have. I'm sure that I've messed this up in some way. But let's go ahead and add the types now that we care about. So we're going to have the plus, even though we don't reference it in the code currently, I'm going to go ahead and add one for minus, and I'm going to call it hyphen minus. See, I don't think we didn't add any other token types, so that's good. Now we have to add the parsing of it. So we're currently not handling that. We don't have anywhere where that happens. We do here say, if we haven't figured out what it is, then we're just saying it's a decimal. So I kind of just want to add two more sets to that. And I'm just trying to think of where should we put them? I'm going to put them towards the top. And since this is only a single character, I'm going to use what we've been doing for single characters comparisons, and we can unify these and clean everything up once we've, well, where's the, there it is. Once we get it figured out. All right, so this is going to be plus. It's going to be the first one. If it equals, it's going to be plus sign. That has a length of 1. And then this is going to be the hyphen minus. And seems like that would be all that's needed. Hey, and that is. So we can, let's go ahead and change that just to make sure. So I'll go ahead and say minus 256 plus 128. That should be a plus. So that should trim off 128 values from our file, and you can see here that it's done exactly that. So if I were to, actually I think that's what this does. Yeah, so we should be looking at 348 or 384. So you can see there, that's exactly what's happening. So that's good. So let's make a commit here. So yep. Yeah, that's got the changes where we took out the else ifs. The update to the grammar. And so what we'll do is we'll say allow for numeric expressions, addition, and subtraction. Okay, so that's great. That's useful. And that's probably all that we need, at least for right now. But we might as well go ahead and add the ability to do multiplications. So again, we're not going to need it in the current example, but it's a good thing to have. So to do this, let's well, let's go ahead, and what we'll do is we'll carve off a little space for us to work, and we'll just say db0 and db I don't know, 2 times 4. I'm just thinking here. I think what I'm going to have to do Well, let's not just think about it. Let's just do stuff and we'll figure it out as we go. So if we wanted to do multiplication and division, it's going to be the same thing as expressions, except we're going to call those terms, or a numeric term. It's going to have the same excuse me, it's going to look the same. So you have to give it a numeric, and then you can say whether you want to multiply or divide, and then what the second part of the term is. We're going to allow them there, and let's say actually I think this will work. For right now, we're just going to allow it only on the defined byte. So you can imagine what we need to do. It's going to be pretty much what we did here. We're going to read the first value, and then we're going to get the next token, and if that token, instead of it being a defined byte, if it is not the end of line, we're going to do this, these calculations in here, and we're going to loop until we get to the end of line. Instead of being a plus, we're going to call it a asterisk. Instead of it being called an add operation, that's going to be multiply operation. Okay. And so, except instead of updating times, we want to just update value. Like that. Yes, so it doesn't know about these things. So let's go and fix that. So multiply is going to be called asterisk, and division is going to be called slash. These are the, if I remember right, these are the ASCII names for those characters. So there we go for that. Okay, so here we're saying, because these tokens have to be, we have to say use them in a U8 context, or just use the 8 bits of it. So we have our output there. If we run the program, we can see that it's in a loop. So let's double check what's going on. So if we get a defined byte, we then look to see what the value is. We then get the next token, and if that token's not the end of line, we check to see if it's an asterisk. If it's not, then we assume it's a slash. We get the next token and get the value out of it and do the operation based off of that. We'll continue to do that by getting the token so long as it's not the end of line. And then at that time, we'll go ahead and output the value. So that seems like it should have worked. It's obvious that it didn't. So let's fire up the debugger and we'll take a look at what happened. Okay, I don't know what these are for, and they're probably all bad spots. So let's just go ahead and put it in here and run. All right, so here's our token. I think values probably something that we care about. That's probably it. So oh, interesting. The token so oh, okay. I'm sorry. Here we are, we're at the asterisk. So the value should be 2, and it is. And we're at the asterisk, so multiplies, oh, it's not. Token type is 0. And that's probably because I forgot to, of course, I forgot to add the parsing detection to it. So that would help. I don't know why. I don't know why that would have looped continuously though. Let's see if this works. And we might go back. It does work, although it doesn't output our values. We're going to have to debug this anyway. But I'm kind of interested to see why it was looping forever. So let's just take a quick peek and see if we can determine that. So we're going to then go ahead and, in this case, the token is, oh, okay. So it's because the length is 0 and the, so we're not advancing forward anymore. So we're stuck on that asterisk. So that's not good. We probably, we probably want to do something else for that. So what I'm going to do is I'm going to go ahead and say, if you get a unknown token, basically let's just consume it, say this was unknown, and let's move on to the next let's move forward one character and see if we can pick up from there. So if we did that, I think then, yes, it will. It does. It does then complete correctly. So that's probably a good thing to keep. Let's go back, and we can remove out those bits. Now what we need to do is figure out why we're not outputting our calculated value for that dB. So let's take a look. So value is 2, token value is 4, so it should go to 8, instead it goes to 0, which is not making sense. So if I say 2 times thank you. Well, I don't know what happened there, but it's obvious that Studio's crashing. All right, there we are. I don't want that. Okay, if we have value, and let's just go ahead and say value times token value. So that's really weird. I wouldn't have expected that. I wonder if this casting it to a U8 is causing a problem. And it's not. So it could be that value is 0, which is bad. So why would the value for that be 0? Oh, well, the current token has a value of 0, that's true. So let's go ahead and consume this. So that should work out fine. When we do this, it gets set to 0. All right, well, that's a little bit unexpected. So I'm going to just do this a little more expressive. We can say here that we'll call it token value is the, I don't know what to say for that, downcasted value. Let's go ahead and then say the multiply value times token value, the U8 this, and then we'll just go ahead and say that we'll give it the multiply value just like a thing on the keyboard. So that still is should technically be correct, but obviously there's some issue with it. So we can take a look and try and troubleshoot what's going on. Oh. Okay, so we were picking the division, which shouldn't be correct. So, so it's coming out as 3, which is the plus sign. So did I just make a huge, well, yes, I did. That should be asterisk plus minus slash. Okay. Let's build. Let's shut that down. So let's build again. We'll run it. And actually, so there we go. So you can see here, we have the jump to loop, our 0 byte, and then the value here, 8, which is 2 times 4. So that was just a typo on my part, which makes sense because the code looked correct where we were looking. So let's get rid of this stuff. And we'll put that line back. And let's go ahead and change our input. Something else. I was going to say 3, but this is going to represent hexadecimal, so that's going to be C, I think. Yep. Okay. So that's good. So now we can do multiplication and division, and I just edited that byte, which I don't want to do. So let's make a commit out of that, because that's a good chunk of code. So we want that, and that. Actually, I don't know if I did all that. Let's see. Let's make this its own commit. And we'll just say here, consume unknown tokens. There we go. Let's change and then allow for numeric terms. And division. Okay, so that's good. We can do multiplication and division in our when we want to define a byte, and we can do addition and subtraction when we want to do times. But what makes it better is if we can do both. The other thing that we want to introduce is a way to be able to allow parentheses so that we can define order of operations. So for example, we want to be able to now say it's not 3 times 4, it's 3 times the, I don't remember what the term is for subtraction, but it's the result of 4 minus 2, 3 times the result of 4 minus 2. Okay. I'm not going to run this because I don't really know what it's going to do, and it doesn't really matter if it works or not because, well, I'm pretty sure it's not going to work. What we want to do is make it work. So I actually messed up the order. I want the order that way, so let's fix that too. And what I want to do here is I want to define a new term called factor. And we're just going to say that it's a numeric for right now. So we're not dealing with the parens, we're dealing just with being able to combine addition, subtraction, multiplication, and division. So if we were to come back here, so this should result in an A in that byte. And so how we're going to change this together is we want to say that for a term, it can be a factor. And for an expression, it can be a term. So this is going to keep the order of operations for us. I'm not entirely sure off the top of my head how, but it just does. So we want to now say, oh, and then let's go ahead and change here to the expression. Okay. So we haven't introduced any new tokens. All we've done is said there's this way where we can kind of just continually call these things. So we can probably inline these let's see. Well, actually, I don't want to do that. First of all, we have them in two spots. We're going to want to be able to do this for defined byte, and we're going to want to do this for times. So we don't really want to figure out how we can kind of glue these two pieces of code together. We want to just be able to have a way where we can call it and use methods to figure this out. So let's see, for right now, let's tokens are the values are U16. So for right now, let's just say, hey, we're going to have some method here. We're going to call it expression. And it's going to get a token. And so the expression was this piece. And our token here I'll come back and fix that. Drop that off. Okay, so for a numeric expression, that's still valid. We get the next one. We do that. And This is going to be a little bit different because we're advancing token and we want to return some value. Okay, throws a little wrinkle in this here. Okay. It's really unfortunate. I don't think that that's going to work. We can try it though. Oh my. Yes. All right, equals cannot do that. This is where I don't think that that's going to work. I don't think that's going to update the token in place. It might, and if so, that would be really neat, but I don't know. So let's find out. So we're at a minus for the 2. Times 512 minus 2. Oh, that does work. Okay. I don't know why. Guess I was worried about nothing. Okay. Neato. Okay, so what this is doing is it's updating what we're passing in an address to the token. When we get the next token, we're updating back to where the token as it's passed in this line. We're updating the values there. with the new token. And then we're just returning whatever the result is based off the add operation. So let's go ahead and do something similar to what is this one? The term. And that becomes that. That's that. Here we go, use 16 result. It's going to be 0. All right. Well, for addition and subtraction, that's pretty easy to deal with on the way out. For multiplication and division, it's going to be a little different. We're going to want to say I'm actually not sure what we would want to say here. I want to try to basically recalculate the number for division into a multiplication so that we can do the same thing that we did for the expression. So I think in order to do that, I think if we say 1 divided by the value, that'll do it. So for example, if we have like 2 divided by 4, and then if I were to say 2 divided by 4 is a half, well, okay, those aren't good numbers. If I said 3 divided by 9 gives us 1/3. If I were to say here 1 divided by 9 is that, and then multiply by 3, that works. So what we want to do here is we want to, all we're doing is we're converting the division into a value that we can use as multiplication. So here we're going to say numeric term, I believe, give it the address of the token, and then here we're going to say value times equals that. Yes, and in this case we have to represent it as a U8. So let's try that out. If we were to say 4 times Can't do that yet. So 4 times 4 is 16 divided by 8, so that should give us 2. I built, yes. And I don't see the value there. So let's just take a look, make sure that this is working the way I expect. I don't want the same file. Let's double check though, that one and this one. So we have this one first, and we are at the times for the 4. So that's 4. So the value becomes 12. That gets zeroed out because we don't have them hooked up yet to feed into each other. So that one's not really helpful as it is. This is now tokens, so we're going to do a whole bunch of minuses, which we know kind of works. So let's fix the data piece. Whoops. There we go. Okay. Alright, so results for what? Come on. Okay, I don't know what happened there. I think the files got out of sync, so we'll rebuild, rewrite it, close this. I'm just going to open it directly. So where were we? We were 3 times. Well, I don't really know where we were. So this is trying to do division of 8. This is the one I care about. Multiply 0, 8. I should go 1 divided by 8. I bet you that's coming out as 0 because they're integers and we need to allow for well, yeah, 1 divided by 8 is going to be some fractional value. Okay. So that's not good. I hadn't planned on that. I didn't want to introduce or deal with floats right now. So maybe what we'll do is we will if we added floats, then all of these values would have to return floats because we're doing that division there. If we, is there another way that we could do it that would make it so we didn't have to have to add floats right now? I'm halfway inclined to just say let's not deal with divisions for now. And I will that one's important, so I'll make a note of that in my to-do file as well. Okay, so if we do that, then that's not possible. We don't have to worry about it. We know that if we did this, it'll come back as 10, which is hexadecimal 60. So that's good, that works. Let's move on to combining these two things together. Right. Oops. So if we what we now can do is what we now should say is that it can be either a decimal or a hexadecimal, basically a numeric, or actually what we should do is I think if we go ahead and just introduce numeric factor, now here where we have the token value, we want to say numeric factor. There we go. And then here, what we want to do is say numeric term. So that's how we can chain them together. Something about that though doesn't feel quite right because it's gonna, this kind of feels like you have to have an addition and then in order to get into being able to have a multiplication. Let me check something real quick. Yes, that's right. Okay. So what we want to do is we want to flip the conditions on when we call numeric term. Is that still right? That isn't. If we change this to a do while loop, okay, so let's think about this. This gets changed. Okay, this is feeling better. What we want to do actually when you say an expression is first go say, okay, go handle the term case and then come back to me. And we're going to want to continue to call term so long as the current token is instead of decimal, it's going to be a plus and a hyphen minus. So while we're continuing to get those tokens, call the numeric term. We're going to want to do something similar here. This is going to be, what do we call it, asterisk and slash. And then that's going to say, go get me the numeric factor. Continue to do that while you're getting asterisks and slashes. Okay, so if we have an expression, oops, and we have something like 2 plus 3 times 4, that's going to come into the numeric expression because that's the entry point basically. So it's going to say, okay, go do the term, and that says go do the factor, and that says, okay, just return the value of 2. Okay? We want to then consume a token, so that we then go to the plus, and it's not that. So then we don't really do anything. So then that comes back here, and the result returned is 2. The current token is now a plus. So we say, okay, it's a plus. Go get the next one, which isn't quite right. I think what we want to do is something similar here. Consume the plus. Then that's going to be a 3. Wow, that doesn't, none of this. Well, I tell you what, this is getting a little long, and there's no point in me struggling in front of you about it. So let's just go ahead and we'll take that out. We'll come on. We'll put in the old code. What's going on here? No file name for buffer 6. That's true. I would like to delete it, but it's gonna mess up the layout here. So what if I just said delete me? Okay, so we're back to the working binary output. So I will ponder on this problem here a little bit and um, come back when I have a better idea of how I want that to be structured. But for right now, let's go ahead and see what questions we can answer on the chat. So it says, Spence R asks, am I a comp sci major? Yes, I have a bachelor's degree in computer science and programming. Joe, sorry about this, Adam Mita asked, what part of the assembler am I working on? We're just doing some real basic, we're at the basic beginnings. You can see what the input is. So it's not much here, and we're only doing a subset of assembler instructions, just the ones that we need, and we're just working on them and adding them as we need them. The current portion that we're working on is being able to do expressions which allow us, the assembler, to do mathematical calculations on our behalf. Tribute 32 ounce asks, I guess your OS can be on virtual machines, and the answer is yes. So the goal is to be able to boot it on physical hardware, but we can we'll also be able to, if we need to, like write an ISO file and give that to a virtual machine and have the virtual machine boot up into it. And finally, Tribute 32 asks again, how does the ASM invoke computer instructions? So the way that works is, you can see here in the screen behind, we have just a handful of instructions. The label is not really an instruction, it's it's something for the assembler to care about. The real instruction here is jump to loop, jump back to this label. We then fill a bunch of space with zeros, and then we have the boot record signature here at the end. And so this is the output of our assembler, and you can see here that the first 2 bytes, those relate to the jump and the loop. So EB is the instruction for the CPU that says I want to do a jump, and the FE is the location that we want to jump to, and in reality that's -1. So that's saying I want to jump back 1 byte, and so it's going to go back to the beginning, and then it's going to execute jump -1 again. So basically that's just an infinite loop. You can see down here in the bottom corner is our 55AA, which again is the boot record sequence, and that tells the BIOS that this device that it's reading from has a boot sector in it that the machine can boot into. So that's how it knows when it's looking through its devices. That's how it knows which one to boot to. So that looks like that's it for the questions. What we'll do next time is we'll finish off the numeric expressions, and we'll add in a couple of indicators that allows us to know the current line that we're on, and so that we can have this times just automatically update for us without having to even think about it. So I hope to see you then. Until then, have a good time.